I think we can start now. So this is the English course, right? So I need to use English. I need to teach in English. Okay. So welcome everyone to this course. So my name is Ku. Okay. Ku. Okay. So this is the first class after the winter break, and then I hope everyone have a good winter break. Okay, so winter break went so fast. Okay, so today is the first class of this course. The course name is the Digital Logic Design. Okay, so in Korean it is called 설계. Right. So so actually we were locked. So we start a little bit late. So sorry about that. Then so I try to scroll down these screens, but I don't know how. So actually in this course I will use this lecture slide, and then I will write some. I write on this lecture slide. So and I think everyone can see this screen, right? Okay, it's clear. Okay. So because today is the first class of this course, so I will briefly introduce about this course, and then I will also mention why we need to learn this course. So as you know, this is a hardware related course, not software. And then I believe most of the students in this class is the computer science and engineering students, right? And then some actually several students from other departments, but actually this course is the computer science and engineering course. So I believe most students are from Department of Computer Science and Engineering. But even though this is not a mandatory course, right? It is not a mandatory course, but it's related to the very critical course in computer science and engineering called computer architecture. So actually, so in this course, so you will explore about some hardware aspect of computer systems, not software. So if you think about some computer science and engineering, then you may think so. You want to learn about the software, like programming languages, or some machine learning is very hot recently, and the artificial intelligence, something like that. But as a computer engineering and science students, so you need to learn about every aspect of computer systems, right? So computer systems include software and hardware part. Okay, so that's why you need to learn about the computer architecture. It's also the relatively hardware course. Also, so digital logic design is the fundamental course. It's required for understanding the hardware aspect of the computer systems. Okay, so I think that's why you take this course. Okay, so I will introduce about this course. So let's see the object of this course. So you need to know about the object of this course. Okay, so what is the object? It's understanding basic digital logic gate. So as you can see the terminology logic gates. So why? So what are logic gates? So we will learn about the logic gate in this course. And then also you will explore how to design digital blocks. Okay. Why do we need to learn about the digital block design. Digital block design. So it is because our computer systems are digital systems, right? So what are digital signals? What are digital systems? So if a system handles digital signals, then the system is called digital systems, right? So which means that you need to understand about the digital signals or digital data. Okay, very fundamental knowledge on computer systems. So in this course, you will learn about the basic concepts of digital logic design. Okay, so actually it's not difficult. I think this course is not a difficult course. Okay, so actually in this course you will learn about the basic logic gate. So basic logic gate called not and or something like that. Also, because this is the digital logic design course, and then we need to learn about the digital block design. And then actually we implement digital blocks using CMOS technology, so CMOS transistor. So I believe recently you hear about some why semiconductor industry is very critical, right? So recently the United States are focusing on the semiconductor industry. Also Korea. So Korea is very famous for semiconductor industry, like the memory technology. So actually these digital designs are implemented using CMOS transistors. Okay, that is the fundamental device or fundamental block that can implement the very complex digital systems. Okay, so in this course we will also learn about the basic knowledge or some how CMOS transistors work in digital systems. Okay. So actually, this is the relatively low level hardware knowledge. So you may be, if you are familiar with only the software part, then this part may be difficult for you. But it's also, actually, it's very, the semiconductor industry, or also the computer chips are implemented using CMOS transistors. So it's also critical for understanding about the some basic properties of CMOS transistors. Okay, and then in this course we will learn about the Boolean algebra. What is a Boolean? Actually, Boole is the name of a person that designed or that who designed or invented Boole numbers or Boolean logics. Okay, Boole. So actually, Boole is the name of a person. Okay, so we will learn about the Boolean algebra. So Boolean we can so make some equations using this basic logic gate. So actually, Boolean algebra is some kind of some algebra that handles digital signals or some digital logic. Okay, also we will learn about the kernel map. Okay, so kernel maps are used for optimizing Boolean algebra. Okay, and then so we will learn about also combinational and sequential logic design, then finite state machines, also memory arrays. So these are combinational and then sequential logic design and finite state machine and memory arrays are basic digital design related knowledge. And then actually this is the fundamental blocks that can be included in the complex digital design. Okay, and then also this is another important things we need to learn in this course. So in this course, we will learn about the hardware description languages. So have you heard about the hardware description languages like HDL? How many? Yeah, only one. Okay. So I believe you are familiar with the programming languages such as Python or C, C++, or even Java, and some other languages such as the C or Go. But what are hardware description languages? Actually, these are languages, the programming languages. So why do we need to learn hardware? Not hardware. Why do we need to learn programming languages? So in order to implement software or applications, so we need to write code using programming languages, right? With Python or C or C++. And why? So, which means that in order to implement hardware, like actually zero hardware, so we need to learn about the hardware description languages. It's a kind of programming languages, very similar to C or C++. So, and then actually in this course, we will learn about the system Verilog. So system Verilog is the very popular HDL, the hardware description language. And then actually in the computer architecture course, so actually for my course, actually the fall semester, I will teach you computer architecture course. Then actually I will provide the design maps. Then actually you need to know about this system Verilog. Okay? That's why so you need to learn about the system Verilog in this course. Okay. But don't worry about the new programming language. So this system Verilog is very similar to C or C++, but it's simpler than C or C++, right? But some other concepts are included in this system Verilog language. Okay, this is the textbook of this course. Okay, the textbook of this course is the Digital Design and Computer Architecture, and RISC-V edition. I think this is the most recent edition of this book. So actually in the abbreviation form, this textbook is called the DDCA. Okay? The textbook is the Design and the Computer Architecture. So there are many editions, such as the ARM editions and or MIPS edition. But in this course, so we will use the RISC-V edition. And then in the computer architecture course, so we will learn about the RISC-V processors. Okay. So if you purchase this book, then it will be very helpful for also learning computer architecture. Okay, so actually I will cover the half of this book. So as you can see, this book includes the topics in digital design and computer architecture, but I will cover only digital design part. Also in this course, I will use the lecture slide like this. Okay, and then I will also post the lecture slide I will use in this course. So if you can access the Blackboard, then you can find the posted lecture slide. Actually, I posted this lecture slide it's last night. Okay. Also, in this course, we will use the EDA tools. So EDA is the electric design automation. Okay, EDA. And then actually not to use the hardware description language, then we need to learn, we need to use these tools, okay? So it's similar to the compiler. So in order to compile our code, then you need the C compiler or C++ compiler. Also, if you want to use the Python, then we require Python program, right? So it's a similar, it's a thing. In order to use the hardware description languages, so we require several tools. So such as so we will use the COSE Verilog. It's a Verilog simulation tool. Also, I plan to use the Verilog. It's the another Verilog simulation tool. Okay, but these tools are free tools. Okay, and then so I'm not related to this publisher, right? But I recommend you to purchase textbooks. Okay, you need to read contents in textbooks, right? So so I found that recently students do not buy textbooks. Actually, they just read the lectures live, so they just replay the recorded lectures live. But it's not enough. I think it's not enough. So please, so I strongly recommend to purchase the textbook. So actually you can purchase the ebook edition, and then I know the prices are is rather expensive, it's rather high. So actually, if you want to purchase this book in some in Korea, okay, like from yes24, yes24 Kyogo, then I know this is higher. The price of this book is higher than higher than hundred thousand, 10만 원. Okay, but you can purchase the ebook of this edition from this site, and then it's cheaper than the real physical book in Korea. So as I mentioned, I'm not related to this publisher, but I recommend so you to purchase this book, and then I strongly recommend you read the contents in this textbook. It's very important. So this is the English course also, which means that this textbook is written in English, but the teaching in English or the learning in English is not easy. It's not easy for me also, but it's important for your career, also for your study. Okay, and then also reading is very important. Okay, so reading the some English literature, not this literature, reading some English paragraphs or reading some English contents is very important. Okay, right, by this textbook, and then read, and then it will be very helpful for your exam preparation, and then also some this is very a good practice to read the English books. Okay. Much cheaper than physical edition. And then for TJ, so actually, as I mentioned, so we will use the EDA tools, and then the most EDA tools run on Linux operating system. But fortunately, you can use Mac OS. So actually, so I plan to use the COSE Verilog and then or Verirator, and then but you can use these tools on Mac OS. Okay, but in x86 computer systems, so you need to install Linux or you need to use WSL. The WSL means the Windows subsystem for Linux. So I know so some students are not familiar with the CLI. So what is CLI? It's command line interface, right? So actually, I believe you are familiar with GUI, graphics user interface. But so as computer engineering or computer science students, so it means that you need to be familiar with the CLI environment, okay, or some like the Linux or Mac OS. Okay, so I selected these tools because these tools can be run on Mac OS also. So I believe so recently many students have MacBook or some Mac systems. So, and unfortunately, we can use these free tools on Mac OS. Okay, so but just to remember that we require Linux operating systems or Mac OS to run EDA tools. And then also you can use the WSL. So even though you use Windows only, then you can install WSL on your Windows 10 or Windows 11 operating system. And then just click this link if you want how to use WSL. So I will not teach about installing WSL on Windows system, okay? Windows operating system. Also, you can install Ubuntu using VirtualBox. So, so if you want to use the full Linux operating system, then you can use VirtualBox. It's a virtual machine that can run Linux operating system on Windows host, or also even x86 Mac operating system, x86 based Mac operating system. So if you want to use the full Ubuntu operating system, then you can use the VirtualBox. So you can click this site, and then you can find the instructions for installing Ubuntu OS on VirtualBox. Okay, so these are prerequisites with this course. So actually, we will use these EDA tools in 1 month. So please get familiar with the CLI environment. So command line interface of the Linux operating system or Mac OS. Okay. Any question? So if you have questions, then you can raise your hands anytime, then you can ask questions, right? Okay, so my name is Panjaku, and then this is my office, and then so you can visit my office by appointment, okay, or Tuesday or Thursday 1 p.m. And then this is my email address, and then this is that page. Also, we have 2 TAs for this course, and then I will post the TA information on Blackboard. And then my research area is computer architecture generally. And then these are my research interests. So if you are interested in my research area, then you can visit my lab page. And then, yeah, okay, this is also important information. So, so we use the Korea University Blackboard, KU Blackboard system, but I will use the Blackboard for announcement and assignment only. Okay. Also, this Blackboard includes the links to Piazza. So Piazza is the class management tool. So what? But I think, I believe the Blackboard system is not convenient. It's not convenient for students, also for me. So that's why I use Piazza. So okay, I will show you Piazza. Okay, so I need to use the that is my keyboard. I'm not familiar with touch screen. Just a second. Okay. Also, I you can see my shared screen. So this is the page of the Korea University Blackboard, KU Blackboard. And then you can find some the text is a little bit more. Okay. You can find the menu there. Okay. So you can find the syllabus here, also the resources here. Oops. But you can find a Piazza here and then resources tab of Piazza. So and then I will use Piazza for this class management. So if you click the Piazza here, so you need to register to Piazza. Oh, I'm not registered. Okay. So this is the first page of the Piazza. So actually, the first page is the Q&A session, right? So you can post any questions on Piazza under this Q&A page. Also, if you click the resources you have here, then you can find some course materials, like the lecture slides. So actually, this lecture is recorded by Zoom, right? And then I plan to post the recorded lectures on YouTube. Okay, so you can find the recorded lectures here, lecture videos. So this is my plan. Okay, just plan. And then also you can find the lab assignment, this design assignment, and then homework and homework solution and general resources here. Okay. Actually, I will post the lecture slide, and then some course materials on the Piazza. Also, you can post any questions related to this course, or also you can ask about the exams or some assignments also, and then I will also answer your questions. Also, Keys will answer your questions. Okay, so just you can visit the Piazza using this link. Also, you can also use these resources Piazza. And then I will also post the lecture slide on the course materials section here. So, okay. This is the link for Piazza. Now you can click on this link, and then also for sign up, you need the access code. Access code is WDCARV And then you need to join as a student, not an instructor. The instructor is me. And then also I will, as I mentioned, I will post the lecture slides and then the videos. This is just my plan. So I will record the video via Zoom. And then also I plan to post the recorded video. So anyone can post questions and answers also. Okay. And then also you can use the Piazza mobile app. So you can use this mobile app on Android. And then I don't have any Apple devices. I don't know about the iOS system. But I believe you can use the Piazza mobile app on your Apple devices. And this is the first. So this is the example page. So actually I used the Piazza on the previous courses, and then this is the Piazza of the computer architecture course. So as you can see, students post questions, okay? And then TAs post answers, or so I also posted answers for the questions. And also you can use the resources tab. Okay, and then COVID-19. So unfortunately, most restrictions have been removed recently because I believe still the COVID-19 situation is not light, but so I can teach without a mask, right? So I think this is also better for you, because if I wear a mask and my voice is may not be clear, so it is not good for you. So I will not wear a mask. So, but you can wear a mask in the classroom, but it's okay. Or you can also you don't need to wear a mask inside of the class. That's just a recommendation. But if you are tested positive on COVID-19, then you cannot participate in the classes, right? So you need to stay at home. So email me immediately if you are tested positive. So as you can see, I use I record my lecture video using Zoom. So if you are tested positive, then I will provide the Zoom link for this course. Okay. So email me immediately. So, and then I believe if you cannot take the in-person task, so it's an offline exam, if you are tested positive. So email me immediately if you are tested positive. Okay. There's a logistics, and then it's a penalty grading policy. It's just a penalty policy. Okay. So we will have midterm, final exam, and assignment, and lab assignment means the design assignment using system variable. Okay, and then for exam, so it's an on-site exam plan, because we don't need to consider about some COVID-19 restrictions. Okay, and then it's a closed book, and also you can use the basic calculators only. So anything may ask in this course, right? And also for the assignment and lab assignments and exams, you can answer in Korean or English. Okay, because this is, even though this is an English course, so using English is my duty, but it's not your duty. Okay. So you can ask questions in Korean, okay? You can answer also, you can answer in Korean or English in the exam, or lab assignment, or some other homework assignments. Okay, this is important. So in this course, I will not call your names for attendance check, okay? So this is the, so in this course, I will use the self-attendance check system in Blackboard. Okay, so if you see the Blackboard, the left panel here, and you can find the self-attendance check here. So you need to click this link, and then also you need to check your attendance by yourself. I will not call your name during the class time. Okay, I think this is the waste of time. Okay, so please. But so actually in the previous semester, some students missed this self-attendance check system. So so if you miss the 1/3 of these classes of this course, so you will get F. So this is not my policy. This is the policy from government. Okay, so this is a very strict policy. So because in this course we use the self-attendance check system, do not forget about checking your attendance on the blackboard. Okay. So this is tentative schedule of this course. Then this is the exam schedule. So we will take it final during the regular class time. But okay, so it's so we will take the midterm exam on April 25th, and then final exam on June 15th. Okay. Any questions about this course? So I briefly introduced about the this digital logic design course. Any questions?
줌으로 수업 듣는 경우에도 온라인
네, 네, 줌으로 들어도 온라인 체크는 해야 됩니다. 그 출석 체크는 해야 돼요. 그러니까는 so I will just check your attendance using this Blackboard system. So if you take the online classes using Zoom, then you need to also check this self-attendance check system. Okay. Any question? I'll capture this screen. Okay, so even though this is the first class of this course, I will briefly teach about the basic concept. Actually, this I will explain why we need to learn digital logic design. Okay, so this is the hardware course. So I believe some students are not familiar with the hardware systems because so as I mentioned, many people think that if they learn about the computer engineering or computer science, and then they think that they need to learn about the programming languages, right? But programming languages are just languages. Okay, it's just kind of it's not fundamental knowledge. It's a kind of language, like the English or Korean. Okay, so think like this: if you know how to speak Korean or English, but you cannot do anything. If you do not have any fundamental knowledge on your research area or your study area, but if you only how to speak Korean or English, but you cannot do anything, right? It's the same for the computer engineering or computer science students. If you know how to use programming languages, if you know how some syntaxes of the programming languages, but you cannot do anything with these language skills, right? So actually, in the computer engineering or computer science department, you need to learn every aspect of computer systems, and then computer systems include the software part and hardware part. So in this course, you will learn about the hardware part of the computer systems. So why need to learn? So let's think about the terminology of this course. Like means that. So in English, this course is called digital logic design. So actually, you can find the two important terms, digital and logic. So what does that mean? What is the meaning of a digital? So what is the opposite concept of digital? The opposite concept of digital is analog, right? So, but if we mention digital system or digital data or digital signals, then it means we can express some signals or data using digits 0 and 1 only. Okay, so think like this. And so every data or everything in this our world can be represented using signals or data. Okay, so for example, so I'm speaking now. Actually, if I speak, then this is the wave data, like so actually if I speak, then my throat make the media like air vibrated, then you can hear my vibration. So some kind of sound wave or sound signals. But we can represent these signals using analog forms or digital forms. Okay, so digital form means that we can represent signals or data using 0 and 1. And then actually computer systems are digital systems, which means that computer systems handle digital signals, which means the data or signals are represented using 0 and 1 only. Okay, so that means the digital. So, and then opposite term is the analog. Then what is the logic? So why do we need to learn about the logic? It's the logic. So as you can see, logic is a system or set of principles. Okay. Actually, these the systems. Okay, computer systems are very, very complex. So that's why we learn about the computer systems, right? If the systems are very simple, then we don't need to learn about these simple systems. But the computer systems are very complex, and then it changes very fast. So, but these complex systems start from the simple logics. What simple gates? Simple gate blocks. So we learn about some baseline logic that is required for implementing complex systems. That's why we learn about the digital logic. Okay. And why need to learn? Because computer systems are part of digital systems. And then actually recently every electric devices includes processors, which means computers. Okay. So then what are computers? What is the computer systems? If we write some code using programming languages, then if we can run this code using the hardware, like the processor, then it is called the computer systems. And then every device includes the processors, so which means that's why the computer systems are very critical recently. And then, so actually I included this slide the last night. So why need to learn? So I AI-based Microsoft Bing. So recently, the ChatGPT is very hot, right? So actually, I answer. So I post the question on the AI-based Microsoft Bing. I think it's powered by ChatGPT. So why need to learn? Actually, for the computer systems or computer engineering or computer science student. So firstly, the computer science student need to learn is the logic design because it's a fundamental core. Okay, fundamental core. It's knowledge regarding computer hardware. That's why we need to learn about the digital logic. Okay, and then it also helps them understand how complex systems, the recent computer systems are very complex. Oh, it's so complex. But it is built from simple algorithms or binary values. But starting point is very, very simple. Okay. So I think it's similar to the mathematics. So starting point of mathematics is very simple, like 1 + 1 = 2. But the mathematics is actually very complex and then it's difficult to learn. The same to the computer systems. Computer systems are very, very complex, right? But is the computer systems are built from simple algorithm or simple logic gates. Okay. So that is the fundamental knowledge. It's very similar to the 1 + 1 = 2 of the mathematics. And then the logic design also provides a base for learning high-level languages. It means programming languages, higher level languages. It's equivalent to the programming languages or abstractions. The concept of abstractions are very important in the computer science field or computer engineering field. So if you learn about the logic design, then you can also learn about the concept of abstractions in computer systems. Okay? It's very clear, right? It's very smart. It's powered by ChatGPT. Okay, I need to learn because the software and hardware. And then this is the video from the computer architecture textbook. So you can see the software is software guys. The software guys or some software things are playing on the instruction set. So it's actually instruction set architecture. And then as you can see, the hardware things or hardware person is under this instruction set, and then this person is the base of this entire computer system. So actually, the software can run the hardware system. Okay, which means that as a computer engineering student, and you need to learn how hardware learns instructions, then software. Okay, so that's why you need to learn about the hardware system of the computer, hardware aspect of the computer systems. Okay, so it's very similar. Actually, I made this slide and I included this slide from the Microsoft Bing. It's very similar, right? It's very fundamental and then very knowledge for understanding computer hardware systems. So why do I teach these things? Why do I say about the motivation of this course? Because the motivation, I think the motivation is very important for learning something. So if you know exact object or exact. So if you know, if you can be motivated by some knowledge, then I think can also focus on this classes or this course. Okay, so that's why I'm talking about why we need to learn digital design. Okay, also it is required for mandatory course, the computer architecture course, the COSE222. Okay, and then actually I will teach about the abstractions in computer systems in the next class, but I will show these abstractions of the entire computer system. So actually, computer systems include many layers. Okay, so as you can see, the lowest layer of the computer system is physics. So physics means it's the electrons. So you know, so if you learn about the physics in your high school, then you know every electric circuits are based on the knowledge on physics. Is it because what are electric systems? So you know the currents are flow from some point to the other point. Then if current flows, actually the electron moves. So it's based on the knowledge of physics, and then divides the transistors or diode. So and then also we can implement the analog circuits using transistors. So if you see the computer hardware, then computer hardware has some layers like the very low layers, like some fundamental knowledge about the physics, devices, or analog circuits. And then above these layers, we have digital circuits. So as I mentioned, we can implement the digital circuits using transistors. But transistors are based on the knowledge of electronic physics. So actually, it's very complex, you know. So we can implement the transistors using some material engineering knowledge, such as the holes or silicons, or like the chemistry, some like the electron, something like that. So we need to learn about some basic, very complex concept of tunneling or some very high level of the physics in order to understand how semiconductor works. And then based on this knowledge, we can build transistors. Okay, the transistor works like the transistor. A transistor works like a switch. Okay, but you don't need to learn about the detailed knowledge about the transistors. And then using these transistors, we can build the analog circuits, because in the real world, we live in the analog world. Okay, actually, the real world is the analog world, not a digital world. Okay, so in order to implement the real hardware, then actually the signals work like analog signals, which means that we need to build the analog circuits, but it's very complex. So we will not learn about these layers of the computer systems. So actually, in this course, we will learn about the basic concept of digital circuits, also basic knowledge on digital logics. Okay, so adders, memories, and then some AND gates, NOT gates, something like that. So we will learn about this part. Why? It is required for understanding entire computer systems. And then above these layers, you can find the microarchitecture and architecture. So we will learn about architecture and microarchitecture in computer architecture course. And then over this part, then there are operating systems, OS, right? So it's very critical. Then also you can find the application software. So if you just know about the programming languages, then it just covers the only this part. Okay, but in order to understand the entire part of the computer system, you need to understand about the each part also. Okay. Okay. So on this slide, I talked about why we need to learn this course, about the digital logic design. Okay, and then I hope you can be motivated by this first day lecture. Okay, and then I hope you can focus on this class, this course, and then you can get some important and valuable knowledge from this course. Okay. Okay, so I will stop here because this is the first day of this course. Okay. Any questions? No. Okay. Thank you for your attention, and then see you in the next class. 감사합니다.